Alright, we're in the second video here in chapter 15, and we just talked about water, how it auto-ionizes to form hydronium ions and hydroxide ions, and you could also say protons or hydroxides, but protons react with water to form hydronium. So we think of a proton floating around in water as the same thing as a hydronium ion because they react so quickly, even though we know they're not the same. We talked about how the change in hydrogen ion, if we put things into water, dissolve them in, or react something with water, if we change the hydronium ion concentration, we change the pH of the solution. So we can calculate the pH and pOH using these equations we talked about last time. So let's go ahead and do some calculations first. That means I've got my calculator out, right? What about you? So let's go ahead. Make sure you know how to use your calculator when calculating pH. Make sure you know how to use it and where the log function is and how to use it. So this first question says the hydrogen ion concentration is 1.2 times 10 to the negative 6th molar. Calculate the pH. Is the solution acidic, basic, or neutral? Well, we know that pH is the negative log of the hydrogen ion concentration, and that's what we're given here. So the pH of this solution is going to be negative log of 1.2 times 10 to the negative 6th molar. Now we can estimate it's going to be a little less than 6, so 5 point something. So let's go ahead and calculate it. So we've got negative log, parentheses, 1.2 times 10 to the negative 6th, close parentheses, equals. I got a pH of about 5.9. So the pH is about 5.9. Now, is the solution acidic, basic, or neutral based on that pH? Well, it's less than 7. pHs less than 7 are acidic. So this is an acidic solution. Alright, let's look at the next one. It says calculate the pH of a 0.015 molar hydrogen ion solution. So once again, let's calculate the pH. It's the negative log of the hydrogen ion concentration, which is 0.015 molar. So we've got negative log of 0.015 molar solution of hydrogen ion. If we calculate that, negative log of that number, I get a pH of 1.8. So the hydrogen ion concentration, that power, the negative log is 1.8 roughly. So what is the pOH? The next question is, what is the pOH of the solution? The pOH of the solution is 14 minus the pH, because we know that pH plus pOH of any solution is 14. So 14 minus pH gives us the pOH of the solution. So 14 minus 1.8, that's going to be 12.2. Now what if I asked you if this was an acidic, basic, or neutral solution? When you're looking at that question, always look at the pH because that's how we defined acidic, basic, or neutral. The pH here, once again, is less than 7, so once again we have an acidic solution. I didn't ask that, but I think it's just, might as well ask that. Alright, let's look at the next one. It says, what is the pOH of a 0.020 molar hydrogen ion solution? Now be careful, because sometimes I ask trick questions like this, just to make sure you're watching. Notice the concentration of the hydronium ion is given, the hydrogen ion. From the hydrogen ion concentration, we can calculate the pH. So pH is the negative log of the hydrogen ion concentration, 0.020 molar. What do I get from that? I get about 1.7. So the pH is about 1.7. But we're asked for the pOH. So this time I indirectly asked you for the pOH. I asked you to calculate pH first, and then you calculate pOH. Remember that 14 minus pH, which was 1.7, gives you pOH. pOH here then will be 12.3. So the pOH of the solution is 12.3. Now, be careful. It says, is a solution acidic, basic, or neutral? The way that we've defined acidity and basicity is based on the pH of